Hi, all. Good evening. Thanks for joining. Let's get started with the most exciting part of the AI journey. I'm sure some of you are at least familiar with what is RAG, what is agentic AI. But this session, we want to cover basically, I want to cover everything from scratch so that it helps us understand each and every component, and it will allow us to start writing some of these agents and RAGs. Okay, let's proceed. So, what is an LLM? Basically, LLM is a large language model. You ask it a question, it can generate any kind of response. So there are different language models, but prominently, when you provide a prompt which an LLM can understand, it can generate as a response. So far so good. Let us also understand what are the capabilities of an LLM and what are the limitations. So when it comes to capabilities, it can answer any questions, it can summarize, it can translate between one language to the other. It can help us write essays and create a lot of content. And nowadays, we are also looking at the vibe coding where agents are being used to write the entire source code from UI till the backend. Everything is done by the agents. There are certain limitations as well. So what are they? LLMs can hallucinate. So when we say hallucinate, although it can generate the data, but it may not be sure that whatever data it has generated, does it even make sense? At times, it could generate, let's say, if we ask any specific product detail, you're working on a specific product and the information about the product is not available online. Now, if you go and ask LLM about that specific product that you're dealing with, most likely it will generate some text for us. It can generate whatever queries we have. It can generate the answers for our queries. But however, there could be cases where it can give us some invalid information that is called as hallucination. So how do we avoid hallucinations? That's where RAG comes into picture, and there could be stale information. So most of these models are evolving every day. However, some of these models could be relatively old, which is not updated with the latest information. In such cases, it may not give us the right responses. Same RAG can help in such scenarios. As we started, especially, let's say I want to deal with domain specific knowledge, which is not available in the market. Maybe it could be a specific product, a specific user guide that you're building for your product. Now, when someone wants to understand uh, a specific aspect in the user guide, now he will have to download those PDFs. He will have to go step by step and understand where is what and how to do it. But with RAG, all of these problems can be simplified. Uh, how they can be simplified, we'll look into it. But predominantly, RAG predominantly started with a chat bot, wherein it can help us uh, generate the content with the knowledge that it has accumulated. And the most important thing for the entire uh, equation is a LLM prompt. So, of course, we can write multiple. There'll be multiple variants of prompts, but typically these four elements are mandatory in any prompt. It can be more than four, but it's better we give all these four elements in our prompt. So we specify an instruction. What is that we want to achieve? It's better we provide some context so that it understands, the LLM can understand and generate accurate answers for us. Then we should also pass the input data, and we can also indicate how the output should look like. So some of these models, they can generate tons and tons of data, while some can reasonably generate very less data. So how do you want to show the output to the end user? So we can also say that, let's say I couldn't find any information in the knowledge base. In such cases, the LLM can boldly say that I don't have much information about this. I cannot provide any responses. So this is how we can craft our prompts so that we get the right output. And there is good article about customizing the prompts. So I've given that reference here. I will move to the next one. So we have been hearing a lot about RAG pipeline. Yes, there are too many components. It sounds little complicated or little overwhelming when we actually begin our journey. But if we look at it logically, the whole equation sounds very reasonable and simple. Uh, what we begin is with the knowledge base. Okay, so we will have the PDFs. We will have, it can be a doc file, or it can be a text file, or it can be an MD file. So all of these represent the knowledge base that we have. But if I open a PDF and if I start searching for it, I will soon run out of what I'm looking for. That's where a RAG can do a better job. So what it does is, prerequisite of the whole RAG equation is, we have bunch of documents. Now I split this document one by one. Uh, So I split this document. The choice is again with the user. How is that we want to split the document? Is it every page he wants to split it, or does he want to split 200 characters, or does he want to create some different chunks? Okay, so that's the first criteria. A big PDF file will be split into multiple chunks. That chunk size the user can define, and as a fine tuning, we have to work on those numbers. Along with the chunks, we can also say that there's an overlap between two different chunks, because the moment we start splitting the PDF, there could be cases where paragraph can be split between two chunks. So if such cases arise, it would be very difficult for the model to give the accurate information. That's where we can have some overlapping chunks. So once the PDF file or the document file or any of these relevant knowledge bases are made available, we process those documents. Basically, we split those documents into chunks, and then we need to store that into a vector database. But before doing that, vector database, as we all know, it is actually a numerical representation of the data. So if we take any classic SQL or NoSQL databases, they will have either data directly incorporated into the database. If I run a query, I'll be able to see some meaningful output. But in case of vector, it's all split into different numerical numbers. Will not be able to make any sense. However, the model or the retriever will be able to make sense. But to get there, we have split the documents. So we have processed the documents, we have split them into different chunks. And before we push them to vector database, we will have to convert all these chunks to something called as embedding with the help of an embedding model. So like LLM, there are different embedding models that are available, which can actually work on the data chunks that we are presenting it to the model. So it takes those inputs, the chunks as an input, and it converts them, groups them wherever they should belong to, and wherever they will have to be separated. So it has its own logic. Let's, for the sake of simplicity, let's not get into the details. But for now, let's understand uh, the different data objects will be chunked and will be embedded, and hence they can be easily saved into the vector database like this. So we, if you look at the vector database, it doesn't make any sense for us because it's all numerical representation. It doesn't have any meaning or any value to us as an end user. But to these LLMs, it makes a lot of sense. So once the uh, vector database, the data is available, now comes the interesting part. A user comes in and he has a query around it, user guide. So we are working on some user guide. So he wanted to understand, how do I configure so and so service? So he will ask this chatbot. Now, what this chatbot will do is, whatever the user has query, that is also fed to the embedding model. It is also converted to a vector. Now, this is used to query the vector database. And once we get the results, so again, when we return the results, there are a lot of options that are available. So I can say I want top 5 results, or I can say I want top 2 results, and so on. So once the query is run against the vector database, we will have the retrieved output. Then we create a prompt and give that prompt to the LLM. So with this, we are also giving what the query is and what is the retrieved content. That is all given to the LLM, and LLM would now generate a much more meaningful output, and that output is now fed to the chatbot again. So when we start a basic RAG, everything will sound perfect because we will just work on one document, and we will assume that whatever data it is generating, it sounds really logical and meaningful. But the more and more we test it, the more and more data we provide, that's where even even in RAG cases, we will have hallucinations. So that's where there are a lot of optimization techniques that are available across each stage. Now, uh, to make it very clear, what is RAG? So we retrieve the required or relevant data from a database, uh, and then we augment the retrieved information to provide prompt. Finally, the prompt is given to LLM, and LLM generates the user. um it generates the response that the user is expecting. So this is all about RAG. RAG would retrieve, it would augment, and that it would generate uh, the final output that the user is expecting. So let's quickly look into some demo. This demo, there are multiple ways to run any model. Uh, for this demo, I've chosen a local LLM. I have installed Olama in a container, and uh, let me list the models that are present in this Olama. So there are 3 models. I need one more important model. So to get a model to my local laptop, I will have to do a Olama pull. So this is very similar to Docker pull. Uh, it actually pulls the image from the public repository and makes it available. Okay, the image is now downloaded or the model is downloaded. Olama LS will display the different models that are available. PS would show the running models. Right now, there's no model active. That's why the output is empty. Now let's look at the example that I'm going to show. Basically, I've picked a simple example that is available in internet. I've taken it from this repository. I've shared the link as well. So this link is provided. Now let's run this demo. Before we run that, let me show you the source code. Let me show you some important aspects. So I'm running Olama in my laptop, and then the embedding model that we are going to use in the vector database. Finally, we're going to chat with the LLM. Okay, let's run this. As we can see, it has created a lot of chunks, but I've not shown what chunks it is creating. Let me show that as well. So we have taken one file, a text file. Instead of a PDF, we have taken a text file, which has a lot of details about cat. So this is the text file. As you can see, there are plenty of lines written about cat. They're all unstructured. They're all present in just one flat file. Now, what RAG would do is the first stage is I read the file and then create the chunks, split the entire text file into multiple chunks. So it has created 150 chunks, and it starts loading all of these chunks. It converts them to embed and stores them in the vector database. Now it is asking us, ask me a question. Copy paste. Tell me about cat speed. So this guy has retrieved, and it is also showing what is the similarity. Okay. And finally, he's trying to give a response. According to the information provided, a cat can travel approximately at 31 kmph, and so on. This is how the LLM has generated. All of this is coming from the Olama models that we are running here. Now, if I go here and run Olama PS, we can see that there are two models up and running. Okay. There is one more pretty fancy or heavy project you can actually look into. This has all the permutations and combinations that are available with RAG. So it actually is pretty heavy. I wouldn't recommend to try it, but you can use this as a reference. Let me show. So it would have a lot of details. We don't have to understand in the first go, but the more and more you start designing RAG and start working on RAG, this would find a favor for you. This could be a good reference point for you. And fine, we heard about RAG, but we don't want to stop there. We actually want to try it out, either in a local laptop, or maybe we can use some of the models that are freely available. So I'm going to show one use case or one option where we can actually start developing something right away without using any credit card. So if we have to go with any public models, typically there's a key mandatory. Even for OpenAI, you need to provide the credit card, although they would give you free credits. But you will, I'm sure you will run out of them very soon. So the alternatives could be Microsoft GitHub, um, or the Google AI Studio, which is the Vertex, or we can use Watson LLMs as well. Or if your laptop supports running WSL2 and you want to try everything locally, you can also run LLMs locally using Olama or LM Studio. There are multiple options again. I have been, the demo that I've showed you is using Olama. So I want to show you how to start using the GitHub models. What we have to do is we need a GitHub account. And to create a GitHub account, it is relatively easy. We can sign in using our Gmail as well. So it doesn't need any credit card. Then once you log in, you will have to go to this models page where you find multiple models that are available. Let me pull that here. And then you can play with these models in the playground. I'll show that. And you can also compare how the models would react. And you can start using, and I'll show you all of these now. So we are in the model section. Now let us select one model. Okay. And we can just start giving our prompt or start giving our query. There are some pre-cooked examples. We can use one of that. So this is how we are using a publicly available model. Now, if I want to compare two different models, I just press this compare button. We want to compare, if we type prompt in one of the LLMs, it is automatically copied to the other one as well. Let's go with hello world kind of stuff. Why is the sky blue? As you can see, I was just typing here, but the same thing is copied here as well. Now let's see how two different models respond and how fast they are. This is how we compare two different models. Now let's say I want to use this model. I want to take this forward. Uh, I don't want to just chat, but I want to start developing. So in such cases, we say use this model. Then it would allow us with multiple programming languages. We can select whatever we want. Okay. Then this is also very important. There is this is coming up very new. The Microsoft SDK is pretty new. OpenAI SDK is relatively there in the industry. So I would recommend you start with this, because when we start, it has to be very smooth. So start with OpenAI, and then you create your access token. So you click this button, it would take you to a page uh, wherein you can generate your token, start using those tokens. So This is how you create a token. Now, once you create a token, you will have to copy that to a safe place. If you lose it, you can actually recreate it. So sorry, I didn't see the chat. This is the first time I'm using this platform. I didn't know how it's working. Sorry, a lot of you had a challenge to view my screen. Let me share it again. My screen is visible. Thanks for confirming. Okay. So we are actually at 9:27. Is it okay if I continue for another 10 minutes? Maybe I can rewind and show the demo again. Let me show the demo. Hope my screen is visible. Okay. So this is my local Olama instance. Olama LS will display the images, so display the models that are present in my local laptop. Then PS will show which are the active models. So right now there is no active model. And let's run this program again. This is a simple RAG application, which has uh, all facts about cat. So there are 150 lines. So this model is chunking uh, each of these lines into a single chunk. So there are 150 chunks. They are all converted to vector and they are uploaded to the Chroma DB. Now, when I ask a question, tell me about cat speed. So it retrieved from the Chroma DB or the vector database, and the LLM is actually responding the query that we raised. So the LLM will have all these as an input, and finally, this is what the user would see. Okay. Then I'll show how to uh, access GitHub models. So we need to get into the marketplace, GitHub marketplace. Copy it. Now we are in marketplace. Let's go to playground. Select a model. Selected this model. Let's compare this model against DeepSeek. Now let's ask, why is the sky blue? Both the models are processing the same request. And as you can see, some would be faster and some would provide a lengthy response. So all of these we can control with our prompt. Now, if I want to use this model, if I want to start developing with this model, I will have to say use this model, select your language choice, then go with OpenAI SDK, and then you will have to create your token. Once you have the token, you go ahead and install the dependencies in your laptop. So here I would like to give a caution. So typically pip is a little risky to use. So unless you use virtual environment or a different technique, you will run into problems. So the simplest way would be, if at all you're using your laptop, if it has a virtual machine or a Linux-based virtual machine, start your development work in that virtual machine rather than doing it on your host laptop. Okay, so you just you can copy this and you can start developing your applications. You can also build your RAG applications. Okay, so we have spoken about this. Then Visual Studio, I'm sure most of you would have heard of Cursor or Bolt, which are kind of very useful for vibe coding. Visual Studio has also released the agentic mode. Now, in the agentic mode, all I can do is just prompt uh, with just the prompts. I can start developing my application, be it front end or be it back end. Everything is doable via the chat. So the recommendation again here is to use one of the Claude models rather than going with GPT. This would give us a better result. And you want to see how much of tokens have you utilized? You come here, you hover here, it would show you what is your utilization. Now, when we want to build the complete RAG stack, so you would need a front end wherein the user will type a query. You need a API layer or the back end, which actually takes a request from front end and it um, talks to the LLM behind the scenes. It also interacts with the vector databases. So you also need a embedding model, which actually takes the chunks and converts them into different embeddings. Then you have the vector database. There are multiple choices. For each of these, there are different choices. LLMs also, there are a lot of options available. So a RAG stack, a basic RAG stack would look something like this. However, the more and more you start using it, it can become more and more complicated. You can start adding some agents as well to your RAG. So a sample RAG that I had created. So I had created a UI wherein I had given an option to either switch between the local or use the public models. Then the choice of selecting the different embedding models so that I can understand better which one to go with and how the behavior changes when I switch between these models. Uh, and there's also an option to upload your files. This is one more variant of a RAG that I have created. Basically, as on date, there are models that can do text to SQL. But when I was looking at models, if there's any uh, open source or community-based models that can do the same for MongoDB, I was struggling. And the more and more we started looking into it, we realized that it is not straightforward to create a RAG that connects to a Mongo database, because it has to understand the database schema. It has to understand what each collection has and how to retrieve the information. So we struggled a bit on those fronts, but towards the end, we managed to build a MongoDB query generator, which takes a simple user input, and behind the scenes, the user input is again converted to embedding. And the vector database is not plain vector database, as we saw a little earlier. We had added a lot of data to it and made it so strong such that whenever the query is made, it chooses the right collections to go with. So that's how we have built this. And then uh, towards the end, we have also integrated it with the MCP server. So it can connect to a real database cluster, execute the query, and uh, provide the uh, prompt output. So I also wanted to ensure the RAG gives some metrics which are very essential to understand whether how is he retrieving, how is he confident about the results. So that's where we have added some confidence metrics as well. Uh, what are the next steps to improve the performance of RAG? As we have seen, a RAG pipeline, there are multiple stages. So there is document ingestion stage, and there is embedding stage, and there is vector DB. So in each of these stages, there is a lot that we can optimize, and there is a lot that we can extend as well. So coming to the document side, so far we have just seen PDFs, but actually there can be uh, APIs as well invoked behind the scenes. So I can get the data from a API, or I can get it from MongoDB, or I can get it from a different database, or I can connect to Kafka to get the real-time data. Now, when the user says, are there any faults, live faults? That's where these integrations would help. So that's where we would tend to becoming more and more complicated. So this processing stage is very vital, and there are different techniques how we can improve the performance and how we can get the better results. Embedding model, again, there are different. For MongoDB, I was very specific. There are a lot of models that are available. There are generic models, but I wanted something which understands Mongo language. So that's where when we created that MongoDB RAG, I had chosen a model that can understand MongoDB queries better. So model selection will also play a role. Model selection will also play a role. Then the vector database. So how I populate my database also matters a lot. So if I just create a chunk and just dump everything into vector database, maybe I may not get proper results. Or if I'm just saying I want to search for top 5 queries, what if my actual response is down beneath the PDF? Let's say it's below 200 pages. So I will never be able to make it into the top 5. So there is a lot of scope that we can optimize the data retrieval aspects as well. And finally, when it comes to prompt, I can create multiple templates, and depending on the user query. So let's say if he's asking only about documentation, then my prompt should be different. If he's asking about real-time data, then my prompt should be such that it connects to the database and it gets me the live data. So that's where prompt templates do play a role. We can make use of MCP server, wherein I can templatize all these different prompts and feed that to LLM and let LLM choose which prompt he wants to go with. So, as we just heard, there are a lot of stages where I can improve the performance. And these are some of the prominent ones that everyone should start looking at. And finally, how do I measure it? What should I look at? So when we retrieve, we should understand whether we are retrieving the right data from the knowledge base. Is it matching with uh, the customer's query? Then finally, the LLM will provide a response. Is it relevant? Is it even giving the right answer? So that's where we can actually use another LLM to judge the response, or we write our test cases, or we can have man in middle who understands what is the final output. Is it in line with the expectation and so on? More importantly, latency plays a big role. So now, if your RAG is here uh, and your models, everything is running in cloud, how do you ensure that you get the app latency? And how do you ensure that you have the right infrastructure to deal with? So there's a lot that we have to measure. These are the three important things that I think we should definitely look at. Yeah, that's all I had for the demo and for the presentation. Sorry, I didn't know that the screen was not being shared. We have overshoot at 12 minutes. I don't know how to open up for any Q&A or sorry, this platform is pretty new to me. I was struggling a bit to find the right platform. If there are any queries, please drop in the chat, or maybe you can reach out to me directly. Okay, thank you all. I will end this session. Thanks for joining. Hope it's helpful to all of you.